This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. Previously, we discussed the normal distribution and noted that it is symmetric and the mean, median and mode are all equal to each other and represented here along the line of symmetry. An example of where we might see the normal distribution occurring is the heights of people. If we make a histogram from the heights of a random selection of people, we will find that it is normally distributed. There are more distributions. Another distribution is the uniform distribution. In a uniform distribution, there is no mode or modal class. It is still symmetric, but every value is equally likely to occur in a uniform distribution. We can also discuss the shape of a distribution. The shape of a distribution is influenced by the mean, median, and mode of the distribution. We'll now take a look at a positive skewed distribution and a negative skewed distribution. In a positive skewed distribution, most of the data is at the lower end of the distribution. This causes the mean to have a greater value than the median, which has a greater value than the mode. Furthermore, a positive skewed distribution can also be known as skewed to the right. The tail is longer of a positive skewed distribution on the positive side. An example of where we might find a positive skewed distribution is income. If we made a histogram for the income of a random sample of people, we would see there are very few high earners and a lot of low and medium earners. In comparison, when we look at a negative skewed distribution, the mode has a greater value than the median, which has a greater value than the mean. The tail is longer on the negative side of the distribution. Most of the data in a negative skewed distribution is at the higher end of the distribution. It can sometimes be known as skewed to the left. An example of a negative skewed distribution is retirement age. If we made a histogram for the age a random sample of people retired at, we would see that most people retire at a later age, between 65 and 70, whereas we would have few people who retired before then, maybe at 50, 55, 60. In this case, most of the data, the retirement age values, are at the upper end of the distribution. In some cases, the data can have more than one mode. If the data has two modes, the distribution will be bimodal. We can see the distribution has two equal sized peaks. This is how we know that this is a bimodal distribution. If the distribution had more than two modes, it would be called a multimodal distribution. On the Leaving Cert, you could be asked questions regarding the symmetry and skewness of a distribution, or on the standard deviation of a distribution. Referring back to the standard deviation video, a small standard deviation would have values or the distribution clustered tightly together. In comparison, a larger standard deviation would have the values more spread apart. That concludes this video.